Imagine all the world's nuclear weapons detonating simultaneously in a single location. This video explores the immediate and long-term consequences of such a catastrophic event, going beyond simple explosions to examine the complex interactions that would unfold. We'll focus on plausible scientific projections based on current understandings of nuclear physics, geology, and climate science. Let's begin understanding what would happen. This visualization represents our planet with a single detonation location marked. The scale bar provides geographical context for understanding the scope of potential devastation that would follow from such an unprecedented event. The combined yield of all nuclear weapons is estimated to be in the gigaton range. A detonation of this magnitude would generate an unimaginable release of energy in the form of heat, light, and radiation. The immediate vicinity would be vaporized, creating a fireball tens of kilometers in diameter. The initial shockwave would flatten everything within a vast radius. To provide perspective, here are visualizations of nuclear explosions of varying yields. The immediate shockwave from a nuclear explosion travels at supersonic speeds, far exceeding the speed of sound. This powerful pressure wave levels structures and causes widespread destruction extending hundreds of kilometers from ground zero. The extent of destruction depends on factors like the weapon's yield, terrain, and atmospheric conditions. A typical high-yield nuclear weapon could devastate an area hundreds of square kilometers. Even at moderate distances, buildings collapse, infrastructure crumbles, and the landscape is permanently altered. The scale of devastation is immense, affecting entire cities and regions. This immediate shockwave represents just the beginning of the catastrophic effects that would follow a nuclear detonation. The intense thermal radiation emitted from a nuclear blast would ignite widespread fires, creating a firestorm that engulfs entire regions. These fires consume everything combustible, releasing massive amounts of smoke and soot into the atmosphere. This contributes to the next phase of destruction, with catastrophic scale affecting vast areas. A powerful electromagnetic pulse would be generated, disabling electronic devices and infrastructure across a vast area. This would cripple communication networks, power grids, and transportation systems, further compounding the disaster. The immediate radiation effects would be devastating. High doses of radiation would cause acute radiation syndrome, leading to death within days or weeks for those exposed. The tremendous force of multiple nuclear detonations could trigger significant seismic activity across the planet. This seismic energy might cause earthquakes and volcanic eruptions, particularly in geologically unstable regions where tectonic plates meet. Areas like the Pacific Ring of Fire and major fault lines are especially vulnerable, where existing geological stresses could be amplified by the nuclear explosions. The explosion would inject massive quantities of dust, soot, and radioactive particles into the atmosphere. This debris would spread rapidly, initially obscuring the sun and causing a period of localized cooling. The sheer amount of soot injected into the stratosphere from nuclear fires could create a nuclear winter scenario. This soot would block sunlight, causing a significant drop in global temperatures and disrupting weather patterns for several years. Soot particles in the stratosphere absorb sunlight energy and scatter it in all directions, preventing much of it from reaching the ground below. Climate models suggest that a full-scale nuclear war could cause a drop in global average temperatures of several degrees Celsius. This would disrupt agriculture and ecosystems worldwide. This graph illustrates the projected temperature decline, showing a dramatic drop from normal levels that could last for decades, severely impacting global food production and biodiversity. The combination of reduced sunlight from nuclear winter, lower global temperatures, and disrupted weather patterns would devastate agriculture worldwide. Crops would fail across all continents, leading to widespread famine and mass starvation that could collapse societies. Nuclear detonations release nitrogen oxides, which can destroy the ozone layer. This would increase the amount of harmful ultraviolet radiation reaching the Earth's surface, damaging ecosystems and increasing the risk of skin cancer. The increased carbon dioxide levels in the atmosphere, resulting from the fires, would contribute to ocean acidification. This would harm marine ecosystems, particularly coral reefs and shellfish populations. Even after the initial radiation dissipates, long-term health effects would persist. Increased rates of cancer and genetic mutations would affect surviving populations for generations. Radiation affects cell structure by damaging DNA, leading to mutations that can cause cancer and be passed to future generations. The combination of radiation, climate change, and habitat destruction would lead to a catastrophic loss of biodiversity. Many plant and animal species would face extinction. The widespread devastation, famine, and disease would lead to a breakdown of societal order. Governments would collapse and resources would become scarce, leading to conflict and further suffering. The specific location of the detonation would influence the severity of the consequences. Detonation in a geologically sensitive area could trigger more significant earthquakes or volcanic eruptions. Radioactive fallout would spread downwind from the detonation site, contaminating vast areas and rendering them uninhabitable for extended periods. Despite the widespread devastation, some organisms, particularly those resistant to radiation or able to adapt to harsh conditions, might survive. These survivors could play a role in the eventual recovery of ecosystems. The massive explosion could permanently alter the landscape, creating a vast crater and potentially changing drainage patterns. This geological transformation would reshape the terrain for centuries to come. The recovery from a nuclear winter event would be an extremely long and difficult process, potentially requiring centuries or even millennia to restore the Earth's ecosystems. While life would eventually return, the world would be permanently altered in ways that could never be fully reversed. The most effective mitigation strategy is to prevent such a catastrophic event from ever occurring. This requires international cooperation to reduce nuclear stockpiles and prevent nuclear proliferation. The detonation of all nuclear weapons in one place is a hypothetical scenario, but it serves as a stark reminder of the devastating potential of these weapons and the importance of working towards a world free of nuclear threats. We must commit to nuclear disarmament and global cooperation to ensure humanity's survival and prevent such catastrophes.